Hi students, welcome to Infinity Learn by Sri Chaitanya. I'm your physics faculty Aniruddha, and today we'll be discussing the questions for Grand Test 8, the physics paper. So let's start off with it. The first question says that the string of a simple pendulum is replaced by a uniform rod of length L and mass capital M, while the bob has a mass small m. It is allowed to make small oscillations. Its time period would be. Now over here, what is actually happening? You have the rod. Let's assume that the rod at any instant it is at an angle theta over here, and at the end you have the mass. Now the length of the rod is capital L, which means the center of mass of this rod would be somewhere around here, where the length would be L by 2 and the mass is exactly at that point L. Now when you are dealing with respect to the restoring forces, you know the restoring forces or restoring force would be in this direction, would be because of this m as mg sine theta, and again you would have a restoring force because of this rod over here, that would be given by capital mg sine theta, where capital M is the mass of this rod over here. So we can find what the total torque is. The total torque tau would be equal to the torque because of this, that is mg L sine theta, plus the torque because of this part, which is mg into the length is now L by 2, so mg L by 2 into sine theta. That is going to be the total torque, and that is equal to the moment of inertia into alpha. Tau is I into alpha. So we can put the moment of inertia. The moment of inertia would involve moment of inertia of the rod plus the moment of inertia of the mass. So that moment of inertia would be ml squared. This is the moment of inertia of just this mass, and this rod is turning about one of its end points. So its moment of inertia would be m L by 2, or rather my bad, it would be ml only, m L square by 3. That is the moment of inertia of the rod when it's rotated about its end. This is the moment of inertia into alpha is equal to this quantity over here, where again we can consider this as mg L plus mg L by 2. And this sine theta, for small deviations, this sine theta can be approximated to be theta, which gives you, we can assume a negative sign because it's a restoring torque. Now from here we get alpha is equal to this divided by this multiplied with theta. So this divided by this is your omega square. So your omega would eventually come out to be, let's do it here because we are running short of space. So your omega would actually be root over of this quantity. Again you can cancel out one of the L's from this side and this side, won't really make a difference. So the root over of that quantity, which is mg into mgl by 2, so 2m plus 2mg plus mg divided by 2, and this would be in the lower part because this would be in the denominator, that would be 3m into L plus m into L, the entire thing, divided by 3 over here. So t is equal to 2 pi by omega. If you do that, you will get 2 pi divided by the reciprocal of this, so that will give you root over of this will go up, so you can take the L's common, so 3m plus capital M divided by, you have a L out over here multiplied with an L, and you have a 3 down, you can even keep the 3 here for now, and this would be in the denominator, that would be 2m plus capital M. Again the g is out and you have the 2 will be multiplied up top. So that is our answer. So based on what we see here, that is this option over here, option 2. Next question, a spherical hole of radius r by 2 is excavated from the asteroid of mass as shown in the figure. The gravitational acceleration at a point on the surface of the asteroid just above the excavation is. So how do you proceed with the sum? Originally when there was nothing excavated out, we know that the gravitational field at that point was given by gm by r square. It's given by gm by r square, where m was the entire mass of the planet. Now next, what do? We have excavated out r by 2. Now firstly we have to find out what is the mass of this part that has been excavated out. So the mass we can find out, the density has to remain the same. The density remains the same, so the density rho is equal to the total mass divided by 4 by 3 pi r cube. That was the actual density. So that means we can find what the mass of this is. That is just the mass m dash is equal to rho into v dash. Since this has a radius of r by 2, we can put the value of rho m by 4 by 3 pi r cube, and v dash is just 4 by 3 pi into r by 2 whole cube. So that gives you r cube by 8. Now these parts cancel out, you'll eventually get m dash is equal to m by 8. That is the mass of this part over here. Now let's understand, this entire field that was there originally, that we can think of as being the gravitational field because of this piece plus the gravitational field because of whatever is the remainder of the piece, right? They both together originally, even though they seem like one body, we can assume that they were separate bodies. The combined effect was this. So what would be the effect because of just this piece? That would be equal to gm dash divided by r by 2, because r by 2 whole square, because now r square has become r by 2 whole square. This distance is just r by 2 plus whatever is the acceleration due to gravity because of the remainder of the piece. We don't need to do much. That is exactly what we need to find out. Let's call that g double dash. This is what we need to find out. They want the gravitational acceleration on the surface of the asteroid just above the excavation. So they want it over here. So the rest of the piece has this acceleration. Now from here on out, we can get, actually, if you put m dash equal to m by 8 and r by 2 over here, this 2 sends it up to make it a square. So your g dash becomes equal to gm by r square minus gm by 8 into r square, and this 2 square goes up as a 4, cancel out, you get a 2. So your g double dash becomes gm by 2r square. Gm by r square minus gm by 2r square gives you gm by 2r square. So correct option is option 2. Next question. This one says that 10 gram of ice at minus 20 degrees Celsius is dropped into a calorimeter containing 10 gram of water at 10 degrees Celsius. Specific heat of water is twice that of ice. Neglect heat capacity of calorimeter. When equilibrium is reached, the calorimeter will contain. Now over here, you see that originally what you would think is you need the ice to cool down to 0 degrees Celsius, then you want the ice to melt, and then you eventually figure out how much water is there. But if you look closely, then you can observe something. Let's assume that the specific heat of ice is given by Ci, right? So in cooling, in this 10 gram cooling of ice from 20 degree to 0 degree, the actual heat that it needs to gain would be 10, let's call this delta of I, energy gained by the ice, 10 gram, we'll keep it in grams, doesn't matter, into the Ci. Ci would denote the specific heat capacity of ice multiplied with the temperature drop, that is 20 degrees Celsius. So that makes it around 200 Ci, right? And on the other hand, let's see how much temperature it takes for the water at 10 degrees Celsius to go down to ice at 0 degrees Celsius. To go down to water at 0 degrees Celsius, because only then can the water start converting to ice. So delta W would be, the mass of water is again 10 grams as is. The specific heat capacity of water is twice that of ice, so 2 Ci, and the temperature change that has to happen is to go from 10 degrees Celsius to 0 degrees Celsius, because that's the temperature of water. So 10. So you see this will also come out to be 200 Ci, which means the energy that this water loses to come down to 0 degrees Celsius is exactly the amount of energy needed by the ice to come back to 0 degrees Celsius. So there will be no phase change. No amount of ice will melt, no amount of water will freeze into ice. The water will come to 0 degree, ice will come to 0 degree, that's it. They are at the same temperature at that point. Which means this 10 gram of ice and this 10 gram of water will stay as is. So your correct option is option 1. Next one, liquid of volumetric thermal expansion, coefficient gamma and bulk modulus B is filled in a spherical tank of negligible heat expansion. Its radius is r and wall thickness is t. When the temperature of the liquid is raised by theta, then the tensile stress developed in the walls of the tank is. Now over here, firstly, we need that pressure. We need to find pressure because we have been given volumetric thermal expansion and we have been given the bulk modulus. Now we know pressure is equal to bulk modulus into delta V by V, which is the change in volume by the actual volume. Now if the temperature is increased by theta, we have been given the volumetric expansion coefficient, thermal expansion coefficient gamma, which means we can write this as B into your delta V will become V gamma into theta and divided by this V as is. So V and V cancel out and you have the pressure in there as B gamma theta. Now this is the pressure acting on that hemispherical ball over there. So we need to find, in order to find the tensile stress, we first need to find the force, then divide the force by the area. So let's understand what the diagram actually looks like. If I take a hemisphere, whatever is the hemispherical shell, whatever is the full shell, if I cut it up, think of a hemisphere, then the hemisphere is going to look something like this. And it's going to have a thickness to it. The thickness is given, that thickness of the walls is given as T over here. Now first up, the pressure is acting and we need to find the force. Force is pressure into area. Now pressure is acting throughout this region, so if I want to find the perpendicular force, that is the pressure multiplied with the perpendicular area. The perpendicular area, if the radius is r, the radius of it is given as r, then the force is equal to pressure into area, that is B gamma theta, the pressure, multiplied with the area, that would be pi r square. So that is my force. And the stress, the tensile stress, is equal to the force divided by the area. Now the force is B gamma theta into pi r square, and the area that we'll deal with is no longer the full area, because even though the overall force that comes about because of the pressure comes because of this entire area, the actual force on the material, the force where the places where the force is acting on the material only occurs in this thickness of the walls, and the area for that is 2 pi r into t. 2 pi r into t, because 2 pi r is the circumference into that thickness t. So it's just like the formula for a rectangle, you can think. If I open it up, instead of the circular ring, if I open it up, the length of that would be the circumference, 2 pi r, thickness would be t. So that is what we put in here. We cancel out some of the terms. This would be capital R, by the way. So we cancel out 1 r from here, we cancel out the pi, and we have B gamma theta r, B gamma theta r divided by 2t. So do we have an option for that? B gamma theta r divided by 2t. So this is our correct option here. Let's move on. The next question says a container A is constantly maintained at 100 degree, insulated container B at 0 degree. Different rods are used to connect them. For a rod made of copper, it takes 30 minutes for the ice to melt. For steel, it takes 60 minutes. These rods are connected as such in parallel. So how long will it take for the ice to melt over here? Now initially when one of them is connected, so each time they're melting the same amount of ice, which means the amount of energy to be given remains the same, that Q value remains the same. So first for copper, it will be Q, the energy that has to be given, we'll assume that to be Q, and the time it takes is 30 minutes. Where is it? It's 30 minutes over here. So Q by 30 is equal to delta theta, which is just the temperature difference, 100 to 0 degrees Celsius, that's 100, divided by RC. RC is the thermal resistance of copper. that RC is equal to KCA divided by LC. Right, Kc into AC divided by Lc, we write it as thermal resistance. Why? Because in parallel it's easy to find the equivalent. Now this is for copper. Same way for steel, when you do this for steel, you would have the same energy because same amount of ice has to be melted, but it's doing it in more time, 60 minutes. The temperature difference is still the same, and the thermal resistance would now be for steel, Rs. So this is for steel. Now we know that when you combine them together, you're essentially connecting in parallel, which means the equivalent thermal resistance 1 by R is equal to 1 by Rc plus 1 by Rs. And at that time, you have the same amount of energy to be transferred, and the time it will take is T in this case. That T is what we need to find. And that has to be equal to the same delta theta, it's still maintained at 100 degree, divided by R equivalent, which is the equivalent thermal resistance. So R 1 by R equivalent is 1 by Rc plus 1 by Rs. So you can write it in that form, 100 into 1 by Rc plus 1 by Rs, which if you expand this up is just 100 by Rc plus 100 by Rs. Now see, 100 by Rc is Q by 30 and 100 by Rs is Q by 60, which means we can even write this here itself, Q by 30 plus Q by 60. Now the Q's you can cancel out and you would eventually have 1 by T is equal to 1 by 30 plus 1 by 60, which means T is equal to 30 into 60 divided by 30 plus 60. This is 90. 90 goes with 3 here, 3 goes here with 20. So your T is equal to 20. Your answer is 20 minutes. The next question says that 1 mole of an ideal monoatomic gas is enclosed in a chamber at 300 Kelvin. The gas undergoes a process in which pressure is proportional to the volume. At the end of the process, volume of the gas is doubled, change in internal energy of the gases. Now, since the pressure is directly proportional to volume and the volume is doubled, firstly it means that V2 is equal to 2V1. And because the pressure is directly proportional to volume, it also means that P2 is equal to 2P1. Now let's try to find the internal energy. Internal energy delta U is equal to, for generally NCV dt, CV for monoatomic gas is 3 by 2 R, so it's going to be 3 by 2 NR delta T, right? And delta T can also be represented as delta PV by NR because it's an ideal gas. So PV is equal to nRT. So delta T would be delta PV by NR. So we can represent it in that form. Do it here itself. 3 by 2 NR into delta PV divided by NR again. These NR get cancelled out. You don't need to worry about that. So your delta U is 3 by 2 into P2 V2 minus P1 V1. That is the change in PV. So P2 V2 minus P1 V1. Now P2 V2 we already got. P2 is 2 times of P1 and V2 is 2 times of V1, which means P2 V2 would be 4 P1 V1. So 4 P1 V1 minus P1 V1 gives us delta U is equal to 3 by 2 into 3 P1 V1. Now also it's an ideal gas, which means we have been given the initial temperature where P1 V1 was equal to, it's 1 mole, so it's P1 V1 equal to nRT1. It's 1 mole, so N is 1, right? And let's write this nRT1. So P1 V1 becomes, N value is 1, R stays as it is, and at T1 it's given as 300 Kelvin, which is 300 R. We replace that in here and that gives us 3 by 2 into 3 into 300 over here. So we can cancel out, 2 goes with 150, 150 into 9 takes you to, okay, there's also an r here, I missed out this r, let's keep this here. So 150 into 9 gives you 1500 minus 150, that's 1350 r. So we have our option here, 1350 r. Next question, both the strings shown in the figure made of the same material, diameter CD is double that of AB. The pulleys are light, speed of transverse wave in speed 1 is V1 and in the other one is V2. Now firstly, what does the speed depend on? The speed of any transverse wave, V is equal to root over of T by mu, where T is the tension, mu is the mass per unit length. And the mass per unit length, how does the mass per unit length depend on the diameter or the radius? Now they are of the same material, which means that density is the same. And the mass per unit length, mu is equal to the density into the area, into the cross-sectional area. And the area in itself is equal to pi r square. So this is how the mass per unit length depends on r. So mu is directly proportional to r square. Here we have been given the diameter, it doesn't really make a difference since we are finding the ratios. So we know that mu1 or rather mu AB by mu CD is equal to, it said diameter of CD is double that of AB, which means CD will have higher, so it would be 1 by 4. Because CD is 2 times, since it's squared here, so you get 1 by 4 from that. Now what about the tensions? We have got the ratio of the mass per unit length. What about the tensions? Over here you see if this is TA, since it's in balance, this is TA, TAB rather, this is TAB, and this over here downwards would be TCD. So 2TAB is equal to TCD. So that is our relation between TAB and TCD, that 2TAB is equal to TCD. Therefore, TAB is equal to TCD by 2. Now we can find the ratio of their speeds, because since this is the relation, we can tell that V1 by V2 is equal to root over of, firstly V1 will involve TAB, so TAB divided by mu AB into over here divided by TCD into mu CD, right? So TAB is equal to TCD by 2, you can even bring this TCD down here to get TAB by TCD is half, so you get half from this, root over of half into mu AB by mu CD was 1 by 4, so goes up top, becomes 4 here, cancel it out, and you have V1 by V2 is equal to root 2. So correct option, option 3. Next question, as shown in the figure, in the conductor carrying a current, magnetic field intensity we need to find. So we have these 6 wires over here, one after the other, each at a distance, consecutive distance r. So we know what this magnetic field would be. For the first wire, the magnetic field, let's call B is equal to, would be mu naught I would be the, I is the current flowing over there, mu naught I into theta divided by 4 pi into r, right? That is the magnetic field because of the first piece. Now when you go to the second piece, what changes? Now these pieces don't contribute anything because they are collinear with that point, but it's these curved pieces that contribute, and the only change when you go to the next part, only thing that will change is that the distance goes from r to 2r and the direction becomes negative, because originally magnetic field was in this, the current was in this direction, so your field was in this direction, there it is pointing into the page. So if you keep adding them up, this is how it will proceed. Your first, because of the first wire, it's going to be just 1 because this multiplied with 1. For the next case, when you have minus, this would become 2r and it would become minus, so you just put minus 1 by 2, because if you multiply this in there, you will get this as minus 2r. Next, the third one will be again plus, because it is again in the same direction as this original one, so 1 by 3, again minus 1 by 4, plus 1 by 5, and how many do we have? We have 1, 2, 3, 4, 5, 6. So there's another minus 1 by 6 over here. So you could write them individually, but I've written them straight away in one form, taking this part common from all of them. Then you get this. From here on, it's just basic calculation. You'll just calculate over there and you would arrive at this answer. I'm not going into the calculation, but you can take the common multiple there and calculate. Next question, a small body with relative density d1 falls in air from a height h onto the surface of liquid of relative density d2, where d2 is greater than d1. The time elapsed after entering the liquid to the instant when it comes to instantaneous rest within the liquid. So first up, before it enters the liquid, it is falling through a height h, which means the speed that it will gather up is given by v is equal to root 2 gh. That is the height through which it falls. That is universal. That does not change. Now once it enters the liquid, what is the force acting on it? There's the gravitational force, there's the buoyant force. And the net force is equal to the buoyant force is going to be greater, because you can see density of liquid is greater than density of solid. So we'll write that first. It is going to be v into d2g minus v into d1g. This part is the buoyant force, this part is the normal gravitational force. So the acceleration is equal to this vg into d2 minus d1, taking common here, divided by the mass. Now the mass is equal to v into d1 into g. Cancel out v's and g's over here. So you have a is equal to d2 minus d1 divided by d1. So we have the acceleration, we have the speed, we have been asked to find the time after which it comes to instantaneous rest. That means how long does it take for this acceleration to make that to 0. So we know Newton's relation, v is equal to u plus at. This actually is u, v is 0 because final velocity has to be 0 and acceleration has to be negative. So anyway, it's just this, t is equal to root 2 gh divided by the acceleration, which is, oh, you also, I think, my bad, I made a little error here. There would be no g. There would be no g, which means this g will stay as is. The reason there would be no g is because this was the mass, and in mass there is no g, it's just the volume into the density. So this g stays over here and you have the g multiplied. So when you do this, you will have d2 minus d1 into g, and up top you have a d1 multiplied. So this root g can cancel with this g here to leave a root g down, so it will become root over of 2h by g, and then the rest d1 by d2 minus d1. That is option 2. Next question, it's an assertion reason 1. It says that a particle moving on a straight line with a uniform velocity, angular momentum is constant. That is true. We know angular momentum is given by mvr sine theta, or rather the speed into the perpendicular distance. Even if it crosses, if it keeps going in that direction, the perpendicular distance remains the same with the line of motion. Speed remains constant and everything. So this is true. Angular momentum is constant. Next, angular momentum is 0 when particle moves with uniform velocity. This is incorrect because the first one is correct. So that means our correct option is this. The assertion is correct, but the reason is incorrect. Next one, a body is thrown vertically upwards. Which of the following graphs correctly represents velocity versus time? This is a very standard graph. We know it's this, because when you throw it up, the speed eventually decreases. That is what's happening. The speed decreases. This is the point where it has hit the topmost point, after which its velocity increases, the magnitude increases, but it's in the negative direction. So it moves down over here. Okay. Next, a paramagnetic sample displays greater magnetization for the same magnetizing field when cooled. This is true because when you cool it, then they become better aligned. All of those magnetic moments become better aligned. Also, we know the susceptibility is inversely proportional to temperature. So reducing temperature increases susceptibility, and hence the magnet becomes, like the paramagnetic sample becomes more magnetized. Next, Magnetization does not depend on temperature. This is incorrect because magnetization, like I just said, since susceptibility depends on temperature, magnetization depends on temperature. Only for diamagnets, magnetization won't depend on temperature. But since nothing is mentioned and we're dealing with paramagnetic sample, this is an incorrect statement. So your correct option is option 3, assertion correct. The reason is incorrect. The next question says that an opaque sphere of radius A is just immersed in a transparent liquid as shown. A point source is placed on the vertical diameter of the sphere at a distance of a by 2 from the top of the sphere. One ray originating from the point source after refraction from the air liquid interface forms tangent to the sphere. Angle of refraction for that particular ray is 30 degree. So let's assume that the ray that we are dealing with, something like this, it was a terrible choice, but anyway, after refraction it goes somewhere like this. So now if I draw the normal to it, this angle here is 30 degree, that is given in the question. Now let's name some of the points. Let's name this as point A, this is point B, this point where the tangent hits over here, that point, let's name that as point C, and over here where the ray hits the surface, that is point D. And we complete this, now we have a quadrilateral. ABCD is a quadrilateral. Now in this quadrilateral, angle ADC is equal to 120 degree. Why is that? Because this part is 90 degree and you have 30 degree more. So you have 90 plus 30, 120 degree. So if this is 120 degree, we know this angle and this angle in the quadrilateral are 90 degree each because they are radii that is connecting with the tangent. So that angle is always going to be 90 degree. In a quadrilateral, sum of all angles is 360 degree, 90 degree taken up by this. So this plus this angle would be 180 degree. This is already 120, which means angle ABC has to be equal to 60 degree. Angle ABC has to be equal to 60 degree. Then if I draw, let's change the pen color here. If I draw a connector from B to D, then this angle is going to be 30 degree. Why? Because this line would be a perpendicular bisector, would be a bisector of this angle. Why? Because this side and this side of the quadrilateral are equal. So if you connect the opposites, it's going to bisect that angle. So this angle is 30 degree, which means now in triangle ADB, I can find what AD is. Because AD by AB is equal to tan of 30 degree in this triangle over here. Now AB is just the radius of the circle, which is A, which means tan 30 is 1 by root 3. So AD is equal to A by root 3. AD is equal to A by root 3. So we have got this length. We also know this length, which means we can find what this angle is going to be. And that is important because that itself is the angle of incidence. Because you see this normal and this line are parallel lines. So this eye and this eye are just alternate angles. Which means over here we can put this in. Our tan of I with respect to this triangle here, tan of I is AD. Let's call this point O. Let's call that point O. Tan of I is AD divided by AO. So tan of I, AD we just got is A by root 3. A by root 3 and our AO is A by 2. So it is A by 2. A cancel out. You have tan I is equal to 2 by root 3. If you have tan I is equal to 2 by root 3, you can figure out what sin I is going to be. Let's clear this part out. We'll just remember that tan I is 2 by root 3. So tan I is 2 by root 3, which means from here we can get sin I. How do you do that? You generally, when you go from tan to a sine, you draw the triangle out. you draw a right angle triangle, you assume 2 is the opposite, you assume 2 is this, if this is angle I, and this your base would be root 3, which means this part over here is going to be root 3 square, which is 3 plus 2 square, which is 4, which is just root 7, which means your sin I is equal to your opposite by hypotenuse, so 2 by root 7. Now we have sin I and we also have sin R, because R value is given to us. The angle of refraction is given. So the refractive index of the liquid, N is equal to sin I by sin R. Sin I is 2 by root 7 and sin R is sine of 30 degrees. Sine of 30 degrees half. So you have half, that makes it 4 by root 7. So your refractive index is 4 by root 7 here. Moving ahead, this one says that some energy levels of a molecule are shown in the figure. The ratio of the wavelengths R is equal to lambda 1 by lambda 2. We have to find the value of R. So what do we know? We know that the wavelength emitted, lambda, is always inversely proportional to the change in energy level, which means your lambda 1 by lambda 2 would be equal to delta E2 by delta E1. So that is going to happen. Now delta E2, let's see, this is lambda 2. How much is the change in energy? You go from minus E to minus 4 by 3E, which means the change in energy is 1 by 3E. So we put that in here, it's E by 3, delta E2. And for delta E1, it's this entire change, which is it goes from minus E to 2E, which means it is just E. The change is just E. You cancel these out, you get delta lambda 1 by lambda 2, which is R as 1 by 3. So correct option, option 4. Next question, the power factor of the circuit shown in the figure is, so you have a resistor, you have a capacitor, you have an inductor, you also have an extra resistor over here. So this is 20 ohm, this is 40 ohm. You can understand the actual resistance would be 20 plus 40, 60 ohm, because they are in series. Now first, for the power factor, we need that phase difference, and that we get from the relation tan phi is equal to XL minus XC divided by R. So over here XL value is given as 100 ohm, XC is given as 20 ohm, divided by the resistance is 20 plus 40, that is 60. That makes it 80 by 60, that is 4 by 3. That is your tan phi. Power factor is cos phi. So again, since we need to go from tan to cos, we again construct our crude triangle over here, where this is phi, where the opposite is 4, base is 3, which means this has to be 5. Then our cos phi would be equal to 3 by 5, that is 0.6. So we have an option, yes, it's going to be 0.6. Next question, a diverging lens with magnitude of focal length 25 cm placed at a distance 15 cm from a converging lens of magnitude of focal length 20 cm. Beam of parallel light falls on the diverging lens. Final image formed is. So let's quickly draw out what the diagram is going to look like. So you first have a diverging lens. And after that you place a converging lens. Now this distance has been said to be, it's placed at a distance of 15 centimeter. This is 15 centimeter. And now you bring in parallel rays. Parallel rays come in and they are going to diverge out. And then you have the formation of the image from the converging lens. That we are not concerned with. What we are concerned with is that this converging lens, the object for the converging lens is the image for the diverging lens. And if parallel rays are coming in, we know the image is formed at the focal point of this diverging lens, which means this length is given by 25 centimeter, where the image from the diverging lens forms. Now this is the object for the converging lens. So the object distance becomes 15 centimeter plus 25 centimeter. So it's actually the object distance becomes, let's put that here, u is equal to minus of 40 centimeter, 25 plus 15. Why do I put minus? Because it's on the left side of the mirror, of the lens. F value is given for this lens over here as 20 centimeter. Since it's convex lens, it's positive. Now we can use our relation of 1 by v is equal to 1 by f plus 1 by u. So 1 by v is equal to 1 by 20 minus 1 by 40, which gives you 1 by v is equal to 40 minus 20 divided by 40 into 20. This is going to give you 20. That's going to cancel out with this. You would just have 1 by 40. So your v is equal to 40 centimeter, and it will be a real image because it will be formed on the other side, because the v value we got as positive. So our correct option is option 1. It's real, the distance of 40 centimeter from the convergent lens. Next one, we need the output of the logic circuit. So let's understand. First, this part gives us A dot B bar. This is a NAND gate. So you have A dot B bar. And that A dot B bar on this side is connected to just the A coming in into another NAND gate, which means you have dot A, and since it's a NAND, you have the NOT up top. So and then a NOT. And this is again into a NAND with another, we'll go into that later. Let's see what's happening here. This side you have that A dot B bar connected to a B. You have A dot B bar connected to a B bar, that is connected to a B by an OR gate. And then these two are connected through another NAND gate, which means and then the NOT up top. So we have to see how this simplifies over here. So we'll use De Morgan's law mostly. So firstly, by De Morgan's law, if you have A dot B whole bar, then you can make it A bar plus B bar. That is what we'll do. So this becomes A dot B bar dot A. This bar goes because when I bring this out and put a bar on top, bar of bar takes the bar away, takes the NOT away, plus A dot B bar plus B, and this entire thing will be under a bar, because again by De Morgan's law, when it goes out with a bar up top. Now what else can we separate here? We can separate this out again in terms of A bar plus B bar, again De Morgan's law. So it's A bar plus B bar dot A, and over here I can punch them together. Because by De Morgan's law, A plus B whole bar is A bar dot B bar. So AB, when I put a bar up top, there's already a bar, so that bar goes, but you now have a B bar up top. Okay, you have a B bar up top, and you can multiply this in here. Now this, when you bring this in, you have A bar plus A B bar, and this is going to give you 0 because B into B bar is 0. So you have a plus 0 over here. That part goes away. A bar is again equal to 0, just like B bar was 0, A bar is also 0. So all that you're left with is A B bar. So correct option is option 2. It's only De Morgan's theorem, one after the other. Next, work done by a gas in isothermal expansion is more than the work done by a gas in the same expansion adiabatically, and this is the true statement. Why is this the true statement? Because if you recall, in the PV diagram, I told you that the isothermal curve also looks like this, but the adiabatic curve is a lot steeper. And since the work done is the area under the curve, you can tell that the area under this curve is going to be greater than the area under this curve. So the isothermal case, you'll have more work done. So the first statement is true. Second one says temperature remains constant in isothermal process, not in adiabatic process. Again, this is also true. Isothermal means temperature constant. In adiabatic, it does not remain constant. So both are true, but this does not explain the first one. So correct option is this. Both statements are true. Statement 2 is not the correct explanation of statement 1. Next, a bomb of mass 1 kg initially at rest explodes into 3 fragments, masses in the ratio 1:1:3. The 2 pieces of equal mass fly off perpendicular to each other with speed of 30 meters per second. What is the velocity of the heavier fragment? Now we can break this down and find each of the components and everything, but we can use some intuition, right? We can use some tricks to do this a bit quicker. So since the 2 equal pieces fly off perpendicular to each other, we can assume that they move in the x and y axis. So you have one piece going in this direction, other piece going in the other direction over here. And let's assume that the masses are, even though it's 1 kg, forget that, because we're dealing with ratios, everything's going to cancel out anyway. So we'll treat this 1 kg, 1 kg and 3 kg over there. Okay. So if on this side you have a mass of 1 kg going, your momentum on that side is going to be 1 into 30, so 30 kg per meter second. 30 kg meter per second. On this side you also have 30 kg meter per second. So you want that the third piece should have a momentum which is cancelling them out, cancelling out the resultant of them. Why? Because the total momentum, net momentum, has to remain 0. So when can that happen? That can only happen if the third piece flies like this, making 45 degree over here. That is crucial. Why? Because then you can understand its equal components will cancel with each of them. Because this is, and another reason why you know it has to be that way, because you have 30 over here, then this side, the resultant of these two is just going to be 30 root 2 kg meters per second, and that will have the 45 degree because the x and y are the same. So you know this also has to have 45 degree and it should also have the same momentum of 30 root 2 kg meters per second. Now the mass we considered of the, for that to be equal to 3 kg. So the net speed would be this divided by 3. That would be 10 root 2. So 10 root 2, but we have two 10 root 2s, 45 or 135. So this is 45, but it says with each of the other two fragments, which means with this fragment that goes in this direction, it's 90 plus 45, 135. Same way for this fragment, it is 90 plus 35, 135. So correct option is option 2, 10 root 2 and 135 degree with each piece. Next, a point charge q placed at the centroid of an equilateral triangle. When a charge q plus q is placed at the vertex of the triangle, the magnitude of electrostatic force on the central charge is 0.1 Newton. The magnitude of the net force on the central charge when a third charge q is placed. So you don't need to worry about finding the distance between charges and so on, because there's a simple way to do this. If you have this as your triangle, this is your equilateral triangle, you have this as the centroid where you place your first charge. When you bring the next charge in over here, the force is a repulsive force, it is 0.1 Newton. F is equal to 0.1 Newton. Now when you bring the second piece here, by the superposition, you know it's going to not even notice that this is there. It will exert a force of its own and it will be the exact same force. It might be in the other direction, but it's going to be the exact same force. Why? Because the charges are same and the distance is also the same. Now you have two forces, right? Now you have the other force also, magnitude of the net force when the third charge is placed. So you don't even need it, you know that this is also exerting the same force. So right away you can answer that the force for that is going to be 0.1 Newton. Magnitude of the net force when a third charge is placed at the center first. Okay, so over here, even if you want to find what the net is, you can actually get this from here as well, the resultant. The resultant would just be, this angle is, the angle between these two forces is 120 degree, right? They have not asked for the magnitude for this, but it will be the same answer as you will see, because the angle between these two forces is 120 degree. So the resultant F net is equal to root over of F square plus F square. It's generally a square plus b square plus 2ab cos theta. A and b are both f. So again you have 2ab, that is again 2f square into cos of 120 degree. This is why it's important to know for the equilateral triangle, this angle is going to be 120 degree. So cos of 120 is equal to minus half. When you bring in minus half, that makes this part is minus f square. Minus half multiplied, the 2 and 2 will cancel, you'll get minus f square, it will cancel with 1 f square over here, and you will eventually have just 1 f square, that would be f, that is 0.1 Newton. Right, so there is how you get this answer. Even the magnitude is exactly the same for both of them. Next, in Young's double slit experiment, slits are horizontal. The intensity at a point P is shown as 3 by 4 Im, where Im is the maximum intensity. If the value of theta is found to be cos inverse of n by m, then the value of n plus m is. Now we know what is the relation for intensity. If the intensity from each of them is I, then is the same magnitude I from each of the slits, then the actual net intensity I net is equal to I1 plus I2, or it would be same I for both of them. It's general. Okay, let's write the actual relation, I1 plus I2 plus root over 2 I1 I2 into cos of phi, where phi tells you about the phase difference between both of the lights coming together. Since I'm assuming they have the same intensity, I1 is equal to I2, which means In is equal to 2I into 1 plus cos phi. 1 plus cos phi. Now we also know that this is equal to 3 by 4 Im, and Im is equal to 4I. Im is equal to 4I, right? So firstly we'll write this 3 by 4 Im is equal to 4I. This is a known fact. You must know this relation, that the maximum value, when can it happen? When this becomes equal to 1, where this will give you 2I, this will give you 2I, the maximum Im would be 4I. So we directly put the relation for the maximum here, that is equal to 2I into 1 plus cos of phi. Few things can cancel out. You can cancel, you have 3I, you have 2I out here, so your cos phi would be equal to half. So your phi value would be equal to pi by 3. Now we need the path difference. Now what is the path difference with regards to this? The path difference is this length. Path difference is that length, that we'll call that as, say, x. So we know how to relate the phase difference with the path difference. It's given by x is equal to lambda by 2 pi into phi. So x, if you look at this right angle triangle, then x, if this length is 2 lambda, that is the hypotenuse because this is 90 degree, then x is equal to 2 lambda cos theta. 2 lambda cos theta, that is x, and equal to lambda by 2 pi into your phi value we got is pi by 3. Cancel out the pi's out here, cancel out the lambdas. Your cos theta is equal to, 2 goes down, 2 into 2 into 3, that is 1 by 12. So your n is equal to 1, m is equal to 12, which means your n plus m is equal to 13. 1 plus 12, that is 13. Next question, a liquid flows through a horizontal tube as shown. Velocities of liquid in the two sections which have areas of cross section A1 and A2, and V1 and V2 respectively. The difference in the levels of the liquid in the two vertical tubes is. So first off, by the equation of continuity, we know that A1 V1 is equal to A2 V2 to V2, which means V1 by V2 is equal to A2 by A1. Have we been given the areas of cross section? It said that A2 is 1 by 4 times of A1. A2 is 1 by 4 times of A1, so V1 by V2 is equal to 1 by 4, which means V1 is equal to V2 by 4. Now we'll move to the Bernoulli's theorem. And mind you, this is a horizontal tube, which means H is going to remain the same, density is the same. So we'll just deal with the, we'll just be dealing with the forces over here. We'll just be dealing with the velocities and the pressures. And the relation then becomes half rho V1 square plus P1 is equal to half rho V2 square plus P2. Okay, that is your Bernoulli's theorem without the height component in there. Right, now over here we'll get P1 minus P2 or P2 minus P1. The speed will be higher here in V2. Speed is higher in V2. That is why here the pressure is going to be low. So we'll deal the H correspondingly. So P1 minus P2 is equal to half rho into V2 square minus V1 square. V1 is V2 by 4. So we'll put that in there as V2 square by 4 square, that is 16. Now this P1 minus P2 is the difference in pressure between these 2 points, and that is what causes the difference in height here. So this P2 minus P1 is just 3h into rho g. So it's going to be 3h into rho g is equal to half rho into V2 square minus V2 square by 16 is going to give you 15 V2 square by 16. Cancel out the rows over here. We need to represent V2 in terms of H into G. So we seem to be already getting there. We will get V2 square is equal to 16 into 2 is 32. 32 multiplied with 332 into 3 into Hg, that stays as is, divided by 15 over here. So roughly you can get an idea that 15 will go with 32 as 6, because my bad, 3 will go with 15 here to give you 5, 5 will go with 32 here to give you 6. So that would be somewhere close to 6. So your answer would be, since we need it to the nearest integer, your answer here would be 6. V2 square is equal to roughly 6 Hg. Next question, magnetic flux through metal ring varies with time according to the relation phi b is equal to 380 cube minus bt square. A value is given, B value is given, resistance of the ring is also given. Determine the current induced in the ring during the interval, the maximum current induced during t equal to 0 to t equal to 2 seconds. Now the current will come from electromagnetic induction, and we know the relation for current, I is equal to 1 by R into d phi b dt. So if we do that in here, 1 by R is given as 1 by 3. Differentiating this with respect to t will give us the 3 stays as is. Let's keep the 3 as is. AT cube gives us a 3AT square, and BT square gives you minus 2BT. So this is the current. We can even cut out this 3 over here. This is the current flowing over there. Now we want the maximum current, and we need the time when the maximum current comes. So we need to first differentiate this. We need to use the maxima method. So differentiating this, what do we get? di dt would give us 3AT square, that would make it 680. 680 minus 2b, and that has to be equal to 0. So the t value that we get from that is that t is equal to 2b by 6a. So if I put b is equal to 6 and a is equal to 2, then we get t is equal to 1 second, right? Which means we have the time when the maximum current comes. We can put that time in the relation for current to get the maximum current. So our I max or Im would be equal to 3 into a is given as 2, so 3 into 2, t square, t is 1 second, so doesn't really matter, minus 2 into, and b is 6, so 2 into 6, 3 into 2 is 6 minus 12, that's going to be minus 6, we'll keep it because we are finding the magnitude. So the answer is 6. Maximum current would be 6 amperes. Did I get that correct? Maximum current is 6 amperes. Next question, a block of mass 15 kg kept on a rough inclined plane as shown. Force 5 Newton applied on the block. Coefficient of static friction between plane and block is, what should be the minimum value of force of P such that it does not move downward. So the tendency is to move downwards, and why is this important? Because this means that the frictional force has to act upwards, has to act along P. So downwards, what are the forces? Downwards the forces are this 5 Newton, Let's not keep the Newton. Let's not bring the Newton in here, that will confuse with the normal reaction force. So 5 minus, you have mg sine theta. So mg is just 15 into 10, 150 into sine of 30. This is plus because both are directed downwards. Minus, you have the frictional force. Frictional force is mu mg cos theta. Mu value is given as 0.5. So mu mg is again 150. And you have cos of 30. That is equal to P. So from here on out, it's just calculation. 5 plus 150 into half minus 0.5 into 150 is again the same thing. 75 into root 3 by 2. That is equal to P. So if you calculate this, you will get a value of P that is roughly equal to, let's use the calculation here, that would be roughly equal to 15 Newton. Not doing into the calculation, you can do that over here. You'll get it as 15 Newton. Next question, consider circuit given below, calculate the charge in microcoulomb on the capacitors. So over here, I'm assuming this is the steady state, which means in the steady state, no current will flow through the capacitor. So this you can consider as a open circuit. This part has been cut off. So what is the actual current flowing? It will flow through just this part. So the total resistance is 1 kilo ohm plus 2 kilo ohm plus 3 kilo ohm. The total resistance is 6 kilo ohm. Voltage is 3 volts. So the current flowing, I is equal to 3 divided by 6 kilo ohm. So 6 into 10 to the power 3. That will give you 0.5 milliampere. Right? Milliampere milli comes because of this 10 to the power 3 down below. So that is the current flowing. Now we have to find what is the potential difference across these two. Forget C and B, that's already an open circuit. We have to find the potential difference across A and D. That VAD is equal to I into RAD, which means the resistance between A and D, and that is 1 plus 2 kilo ohm, that is 3 kilo ohm. So if you multiply this I with 3 kilo ohm, since this 3 here and this 3 here, I can just tell it would be half of this. So that would be 1.5 volt. Now this is also the potential difference across the entire capacitor setup. But these two are connected in series, which means the potential drops would be different, but the charge would be the same. So firstly, let's find the equivalent capacitance. Since they are connected in series, the equivalent capacitance C will be 1 into 2 divided by 1 plus 2 microfarad. That is 2 by 3 microfarad. That is the equivalent capacitance about this. And the charge we can get from this equivalent capacitance and the potential drop across the entire thing, the charge will be the same for each of them. We need to find that charge. So it's just Q is equal to CV, that is 2 by 3 into, this is microfarad, so 10 to the power minus 6, and up here we have 1.5, that is, we represent it as 3 by 2. Why? Because then we can cancel stuff out and we get 1 into 10 to the power minus 6 coulomb. So it's already in microcoulomb, so the answer is 1. Again, is that answer correct? Yup, we have the correct answer. It's just rechecking if the final calculation, the method takes us to the right place. Next, the resistance R is equal to minus V by I. Here V is 50 plus minus 2 volt, I is 20 plus minus 0.2 ampere. The percentage error R is X%. So the percentage error we know, for since its R is equal to V by I, the percentage error, percentage in R is equal to the percentage error of V plus the percentage error of I. What is the percentage error of V? The error is 2 divided by the actual value is 50. Since we're finding percentage, you have the multiplication with 100 plus the percentage error of current, where the error value, the uncertain value is 0.2, and here you have 20. So it's 0.2 by 20 again into 100. So this goes with 2, and over here this goes with 100, 100 goes. So you have 2 into 2, 4 plus 1, that is 5%. So the x is going to be equal to 5. Next, an engine is attached to a wagon through a shock absorber, length 1.5 meter, system with a total mass 40,000 kg, moving with a speed 72 kilometers per hour. When the brakes are applied to bring it to rest, in the process of the system being brought to rest, spring of the shock absorber gets compressed by 1 meter. If 90% of the energy is lost due to friction, spring constant is. So you had the original kinetic energy. That kinetic energy, part of it is lost to friction, and the other part is absorbed by the potential energy of the spring. So that kinetic energy, that the 10% remaining, should be equal to the potential energy of the string at its compression. Before we move into that, we have to first convert this from kilometer per hour into meters per second, because we are dealing with SI and everything else. We are dealing with meters everywhere else. So the simple way to do that is multiply kilometers per hour into 5 by 18. This is going to go with 4. That is going to give you 20 meters per second. That is V. So we have V, and we know that 10% of that is equal to half kx square. So set this apart. We have 10%, which is just 0.1 times of half mv square. M value is given as 40,000 kg. 40,000 m into v square. V value we just got as 20 meters per second. So 20 square. And this has to be equal to that potential energy stored in the spring. That is half k, and the compression is set as 1 meter. So it's just 1 square. Cancel out these halves over here. So this will give us, since they've asked us to find in 10 to the power 5, so 0.1, so this will give you 4 into, this is again 4 into 10 to the power 10 to the power 2 would come in there. So it's 10 to the power minus 1 into 4 into 10 to the power 4 into, again you have 4 into 10 to the power 2. That is equal to k. Now we can do it. It's going to be 16 into the 10 powers are minus 1 plus 4, that is 3. 3 plus 2, that is 5. Equal to k. So we have to represent it in 10 to the power 5. So our answer is 16. Next, a long cylindrical volume contains a uniformly distributed charge of density rho per centimeter cube. Electric field inside the cylindrical volume at a length x equal to 2 epsilon by rho meters is, from its axis is this. So here we'll assume that we take a hypothetical cylinder, inside it having the radius x and a height L. Take a height L over here. Now from this we will have to figure out what is the charge enclosed in here, because that is our Gaussian surface. So the charge enclosed is equal to the density multiplied with the volume. So the density is rho, multiplied with the volume is just going to be, the volume of a cylinder is pi r square L. So pi x square into L, because the radius was x. We have assumed this length over here. This is a hypothetical part. So pi x square L, this is my enclosed charge. Now we know by Gauss law you have E into integration dA, or rather the E is originally in the integration, but it's going to remain constant because we're only finding the electric field about the side regions. These parts don't contribute to any electric flux. Why? Because flux will travel parallel to them. Nothing will cut through it. So it's only this curved area through which the flux is cutting through. So that is why we'll only deal with that area. So there the electric field is constant, and you have this as Q enclosed divided by epsilon naught. So E into, like I said, is the curved surface area of that cylinder, that is 2 pi RL. 2 pi XL is equal to rho pi x square L by epsilon naught. Some things are going to cancel out, your pi's are cancelling out, the L cancels out. That's good because L was just a hypothetical length we had taken. One of the x cancel out as well, you bring the 2 down. So E is equal to rho by 2 epsilon naught into x, and x is given as 2 epsilon naught by rho. not by rho. So everything cancels out. Your answer is 1 for this. Electric field is 1 volt per meter. Next, that's also, yeah, we have got that also down. Next, two concentric circular coils C1 and C2 are placed in the XY plane. C1 has 500 turns, a radius of 1 centimeter. C2 has 200 turns, radius of 20 centimeter. C2 carries a time dependent current given by this. The EMF induced in C1 at time t equal to 1 second is to represent as in terms of 4 by x and then get the value of x. So this is just two circular planes, concentric circular planes. So we know what the value for the mutual inductance of that is. It's a standard relation. M is equal to mu naught N1 N2 into pi of whichever is the smaller one, or through the one through which the flux is passing. This over here, the current is passed through C2, which means we are dealing with C1. So pi R1 square divided by, you have 2 into the other radius, so 2R2. This is the mutual inductance formula. And from here on we can find the current. We need the EMF induced. So EMF is equal to M di dt, M di dt. So M value, this whatever, I am not putting in the values in, multiplied with differentiating this 5t square minus 2t plus 3 gives you 10t minus 2, 10t minus 2, which is equal to M into 10. The t value has been provided as 1. So you will get 10 minus 2, that is 8. So you can calculate here, again I am not putting in, there is not enough space, and the calculation you can do, just find the value of M here, all the quantities are provided, put them in here, and you would get this E as equal to, this E would come as 0.8 millivolts, which, since we need to represent it in terms of 4 by x, that would be 4 by 5. So the x value is going to be equal to 5. Next, two radioactive materials A and B have decay constants 25 lambda and 16 lambda respectively. Initially they have the same number of nuclei, then the ratio of the number of nuclei of B to that of A will be E. After a time 1 by A lambda. The value of A is. So let the time that has passed be T. In that time you want NB by NA is equal to E. Now NB is equal to N naught into e to the power minus lambda t. So lambda for B is 16. So minus 16 lambda t divided by NA would be N naught into e to the power minus, for A it's 25 lambda. So minus 25 lambda t, that is equal to E. So cancel out the N naughts. You can just shift 25 lambda t up top, so that this becomes e to the power 25 minus 16 lambda t is equal to E. So t is equal to, this is just 9, e to the power 9 lambda t is equal to E. So this is e to the power 1, so 9 lambda t is equal to 1. 9 lambda t is equal to 1, therefore t is equal to 1 by 9 lambda. So if you compare with this, you get your A value as 9. That's it. Those were the questions for the physics part. Again, like I said, it's moderate, not easy, but I won't say this to be a difficult paper. You should be expecting, of these 25 questions, you should be targeting at least 20 to 22 questions out of this. If you really want to get in the, if you want to score about 250, 220, 230 in your JEE, you should try to get at least 22 out of here. So that's it from this session. I'll catch you guys with the next paper solution.
Welcome to the video solution of Grand Test 8 Chemistry section. I'm Nitin Verma, a chemistry faculty at Infinity Learn by Sri Chaitanya. So let's get started with the solution. Beginning with the first question, number of atoms in the following samples of substance is largest in? So the correct answer to this question is this, because number of moles is mass upon molar mass, right? So hydrogen is 4 gram and its molar mass is 1 for hydrogen atom, right? Because the question is atoms. In this case, the mass is 71 and the atomic mass of chlorine is 35.5. So this is 2, this was 4. For iodine, given mass is 127 and the molar mass of iodine atom is also 127, so that is 1. And 48 gram of magnesium, number of moles is mass 48 divided by molar mass 24, so the number of moles is 2, right? So the maximum number of moles is in hydrogen. Next question, the shortest wavelength of hydrogen atom in Lyman series. So in Lyman series, electron drops in first state, right? And shortest wavelength is minimum, means energy is maximum. Remember, for maximum energy, the final value, right? So the value of n from where the electrons start, that should be infinity, right? That should be infinity. So the transition is here, emission transition is infinity to 1. Okay. Now the wavelength is what? Energy is inversely proportional to wavelength, right? That we know. So energy is inversely proportional to wavelength, 1 upon lambda, Rydberg constant, all right. Then this is 1 upon 1 square minus 1 upon infinity square, right? So this will be what? They have called it lambda 1. So 1 upon lambda 1 is equal to Rydberg constant, all right. So this is 1 by 1 minus 1 upon infinity 0, so this is 1. Now coming to the Balmer series, in Balmer series, electron drops to second orbit, right? The longest wavelength means the minimum energy, so energy wavelength is maximum, so energy is minimum, so the electron starts from 3, so the transition is from 3 to 2, right? So now this wavelength 1 upon lambda helium is Rydberg constant, and z square for helium z is 2, right? And then it is 1 upon 2 square minus 1 upon 3 square, right? So this is Rydberg constant into 4, and then this is 1 upon 4 minus 1 upon 9. So if we take the LCM, then Rydberg constant into 4, this is 9 into 4, 36, and this is 9 minus 4, 5. Right. So this is 5 Rydberg constant by 9. This is 5 Rydberg constant by 9. Okay. And from here we know that Rydberg constant is 1 upon lambda 1. Right. So this is 1 upon lambda 1. So this is 5 upon 9 lambda 1. So 1 upon lambda of helium is 5 upon 9 lambda 1. If we take the inverse of this expression, then we get that lambda of helium plus is 9 lambda 1 by 5, all right. Okay, so the correct answer to this question is 9 lambda 1 by 5. Moving to the next question, correct order of electron gain enthalpy, of course this, because in group 16, because of the smallest size, in group 16 oxygen has maximum electron repulsion, and that is why oxygen has the lowest value of electron gain enthalpy. This makes sulfur have the highest electron gain enthalpy. The magnetic moment of a dioxygen species is 1.73 bm. Now, the spin-only magnetic moment is under root n into n plus 2, and if it is 1.73, it corresponds to the presence of one unpaired electron, right? So we just have to check in which pair both the species contain one unpaired electron. So these three options are immediately ruled out because they all contain dioxygen, and we know that dioxygen has two unpaired electron in pi star 2px and pi star 2py. This makes the option 1 correct answer, right? If Z is a compressibility factor, then Van der Waals equation at low pressure. So Van der Waals equation for 1 mole gas will be P plus A by V square, V minus B is equal to RT. If the pressure is low, we can ignore the volume of the gas, right? Attractive forces are there, but we can ignore the volume occupied by gas molecules. So if I expand this, this is PV plus A by V is equal to RT, and if I multiply if I divide the entire equation by RT, so I get PV by RT plus A by RTV is equal to 1. PV by RT is nothing but the compressibility factor Z, right? That is how it is defined, and this gives me Z is equal to 1 minus A by RTV. So the correct answer to this question will be option 2, 1 minus A by RTV. the increasing order of the reactivity towards electrophilic aromatic substitution. So chlorine, because of the minus I effect, it is slightly deactivating. Methyl, not a very powerful activator, but still it is an activating group. And COCH3 is a moderately powerful deactivator because of the minus resonance effect, right? So second will be most reactive, followed by first and then third. The incorrect match, okay, so we know that the standard Gibbs energy is minus RT ln Kc, equilibrium constant, right? So by simple mathematics we can tell if this number is greater than 1, so log of number greater than 1 is positive, so Gibbs energy is going to be negative, right? If number is less than 1, log a number less than 1 is negative, negative into negative is positive, so standard Gibbs energy is going to be positive. If this number is 1, then log of 1 is 0, so basically delta G naught is going to be equal to 0. So the only incorrect combination is option 4, because when delta G naught is less than 0, K has to be greater than 1, right? When Gibbs energy is negative, equilibrium constant has to be 1, it cannot be less than 1. A diatomic molecule has BCC structure, so the rank is 2. There are 2 particles per unit cell with a cell edge of 300 picometer. A is given, the density is also given, and the question is what is the number of molecules present in 200 gram sample, right? So there is a simple formula for this. We know that D is equal to Zm by A cube Na, right? Number of particles per unit cell, Z, molar mass of the particle, M, A is the edge length, N is the Avogadro number, right? So if you see carefully, M is the mass of 1 mole particles. So I can modify this formula and instead take this, right? That W is the mass of N particles. That makes your question very easy, right? So the question is the number of molecules present in 200 gram of X2. So that is I have to find N, which is Z W A cube into density. So it's very easy, substitute the given values. Z is given to be 2, mass is 200 gram, edge length is 300 picometer, in terms of centimeter this is 10, right, cube, and density is given to be 6.17 gram per centimeter cube, right. So you can solve this, the answer you will get is approximately 2 mole, right. So here you will get 2 multiplied by Avogadro number, right. Freezing point of 1 mole, this is concentration. Aqueous solution of HF, a weak electrolyte, is found to be minus 1.91. So because the freezing point of pure water is 0, this is the depression of freezing point delta TF. Now we know that depression of freezing point delta TF is I KFM, right? Depression of freezing point delta TF is I KFM. Delta TF is given to be 1.91. Van 't Hoff factor we have to find out. The depression constant of water is given to be 1.86 and molality is just 1, right. So Van 't Hoff factor is 1.91 divided by 1.86. Now the question is what is the percentage dissociation of HF. So remember guys, the Van 't Hoff factor expression is 1 plus alpha n minus 1, where n is the number of particles produced upon dissociation. So HF gives 2 particles, H plus and F minus, right. So I is basically going to be 1 plus alpha because n is 2. 2 particles are produced upon dissociation. So 2 minus 1 is 1, right. So Van 't Hoff factor is 1 plus alpha. I is 1 plus alpha, Van 't Hoff factor is 1 plus alpha. So alpha will be I minus 1. So this is 1.91, 1.86 minus 1, right. And for percentage dissociation, you multiply it by 100. So 100 multiplied by 1.91 minus 1.86 divided by 1.86. So this is going to be your answer, which will come out to be approximately 2.7, right. So that is a percentage dissociation of the HF. Classical smog occurs in cool humid climate, correct. It's a reducing mixture of a smoke, fog and sulfur dioxide, true. Photochemical smog has components ozone, nitric acid, acrolein, formaldehyde and peroxyacetyl nitrate. Yes, both statements are correct. Memory based question. For an elementary chemical reaction, the expression of dA by dt. So remember guys, for this equation, the rate of reaction would be 1 upon 2 dA by dt, right? The rate of reaction is reciprocal of the stoichiometric coefficient and then dA by dt. And if I apply the integrated rate equation on this, then the net rate of formation of A, it will be the rate of formation which is K1A2 minus the rate of consumption which is K inverse A square, right? So now you know what to do. The expression for dA by dt is simply take 2 on the right hand side. So dA by dt, if you take 2 on the right hand side, then you will get this, right? 2 K1 A2 minus 2 K inverse A square. So option 4 is the correct answer. Activated charcoal absorbs sulfur dioxide more efficiently than methane. Yes, because the attractive forces are more for sulfur dioxide. And please remember that critical temperature is proportional to attractive forces. So assertion is correct, reason is not correct, right? Gases with high critical temperatures are absorbed more easily. Pig iron is directly obtained from blast furnace. It is not obtained by cast iron. Incorrect. Pig iron is a relatively higher carbon content because it is directly obtained from blast furnace. It is the highest amount of carbon content. So that is not true, right? So both statements 1 and 2 are false. Oxidation number of chlorine in calcium oxychloride bleaching powder. So you should know that in bleaching powder, if I write it like this only, then this is Ca2 plus, Cl minus and OCl minus, right? That is the composition of bleaching powder, the main ions. So of course, the oxidation number of chlorine is +1 and -1 because it contains hypochlorite and chloride ions, right? The two statements, this is memory based, so 1.74 volt is the value. But remember that if the higher the reduction potential of a substance, greater is its tendency for reduction, which means 1.74 is a very high value, which means cerium 4 plus exhibits a strong tendency to undergo reduction to form cerium 3 plus, which makes the second statement incorrect, right? Because second statement is saying cerium is more stable than cerium 4 plus. No, had it been so, the potential would have been low, right? Negative preferably. So statement 1 is correct, but statement 2 is not. On treatment of 100 ml of 0.1 molar cobalt chloride, .6H2O with excess of silver nitrate, these many ions are precipitated, the complexes. So how do we figure that out? See, this compound, it will give 1 chloride on dissociation, this compound will give no chloride, this compound will give 3 chloride and this compound will give 2 chloride, right? So I just have to calculate what is the equivalent of silver nitrate formed, right? So for this compound, number of moles or millimoles is molarity into volume, right? So the molarity of the this compound is 0.1 and the volume is 100. So this is basically 10 millimole, right? That means I am reacting 10 millimole of the complex with how much silver nitrate? 1.2 into 10 to the power 22 ions are precipitated. So number of moles of AgCl, okay? Sorry, silver nitrate, the reacting with this cobalt chloride, what is precipitated? Silver chloride, AgCl, right? These ionized chloride ions. So how many moles of AgCl we have is 1.2 into 10 raised to the power 22 divided by Avogadro number 6 into 10 to the power 23. So if I adjust it, then this becomes 21 and this is 0.02 mole, right? Or if I convert to millimole, multiplied by 1000, so it is 20 millimole. So we can clearly see if I take 10 millimole of the compound, then it gives 20 millimole of AgCl. That means twice the number of chloride, which makes this option 4 the correct answer, right? Because there are 2 chlorides produced upon dissociation. Oxymercuration demercuration follows Markovnikov rule. It is Markovnikov addition. So positive part H goes to the carbon already having hydrogen atoms and negative part H goes to this. So that makes option 1 the correct answer. Aldehydes are more reactive than ketones and the reactivity is inversely proportional to steric hindrance, right? So HCHO is the most reactive, followed by acetone, then acetophenone and then benzophenone. So the correct order will be A, B, C, D, right? Here the first one is Helvolat-Zielinski reaction. In the presence of red phosphorus and chlorine, the alpha hydrogen atom gets replaced by the halogen, right? So this is CH3, CH, chlorine and then COH. If you react it with alcoholic QH, it undergoes this dehydrohalogenation, beta elimination. So chlorine, and of course from here hydrogen eliminates, we have a double bond, right? So the correct answer will be this. The increasing order of reactivity in SN1. In SN1, the reactivity is proportional to carbocation stability. So we can see, of course, these will be aliphatic carbocations, less stable. These are aromatic resonance stabilized carbocations, right? They will be more stable. They have aromatic components. So this will be stabilized by benzene, not only by benzene but also by OCH3. So C will be most reactive, followed by D. Out of A and B, you will see which has greater extent of hyperconjugation, right? So actually the correct answer will be C, D, A, and then B. Alright, so actually this carbocation will undergo 1,2 hydrate shift to give a more stable carbocation, but then that makes the reaction slow. But still, because it forms more stable carbocation, so A is more reactive than B. The number of chiral carbons in chloramphenicol is 2, because this is the structure of the compound, and you can see there are 2 chiral carbon atoms here, right? This chiral carbon and this chiral carbon. So it has 2 chiral carbon atoms. Memory based question. An acidic solution of dichromate is electrolyzed for 8 minutes using 2 ampere current. This is the reaction. The amount of chromium obtained was 0.104. The efficiency of the process. So efficiency will be very simple. The efficiency will be actual amount right divided by expected amount multiplied by 100. Okay. So actual amount is given, the amount of chromium obtained is 0.104. Expected amount, that we have to calculate. Now expected amount can be easily calculated using Faraday's first law of electrolysis, which says that W is equal to ZIT, right? So Z is electrochemical equivalence, this is equivalent weight, which is 52 divided by N factor, the number of electrons transferred. So chromium is going from +6 to +3, so 3 electrons are transferred, right? So N factor is 3 divided by Faraday constant. I can take 96500. Current is 2 ampere, time is 8 minutes, converted to 60, multiplied by 60 to convert into seconds, right? So this is your W, right? Expected amount. So you put it here and do this calculation. You will find the answer will be how much? You can calculate, right? What is the correct answer? It will be 60%, right? So simple calculation after that you can do. Here you have to find out the RF, which is basically the distance moved by A, which is 2 centimeter, right, divided by the distance moved by the solvent, which is 5 centimeter, which is nothing but 0.4 or 4 into 10 raised to the power minus 1. Here this has to be 2.8, right? So this question would have been a lot easier had the temperature been constant, but because one sample is at 300 Kelvin, another is at 60 Kelvin, so there is going to be heat transfer from hotter gas to cool gas, right? So what we can do here is that heat lost by 1 is equal to heat gained by second, because 1 is at higher temperature, so heat lost by 1 is heat gained by 2. Now heat is NCM delta T, right? Can we say that? Heat transferred is NCM delta T. Now number of moles in first container is 2.8 divided by 28 multiplied by heat capacity. That is not relevant here because it will get cancelled out. Temperature difference, remember that because it will lose heat, so 300 will be higher temperature and the final equilibrium temperature will be low. So to make it a positive quantity, I will write this, right? Then this has to be equal to the heat gained by the second bulb, right, the gas in the second bulb, which is going to be 0.2 divided by 28, right, heat capacity, and because it is gaining heat, its final temperature will be higher than 60. So I will write as T minus 60. So this is a very easy calculation, right? C will cancel out, 28 will cancel out, so this is 2.8, 300 minus T is equal to 0.2 T minus 60. Right, so you can do this calculation, okay, and then you will find that the final temperature is approximately 284 Kelvin, okay, and then you can apply the ideal gas equation, because the question is when the valve is opened, what is the final pressure of the system, right? So that is nothing but PV is equal to nRT, right? So final pressure, volume is 1 liter plus 2 liter, 3 liter. The total volume of the gas will be 3 liter, right? And the total number of moles is 2.8 here and 0.2 here. So with this is 3.0 divided by 28. The value of R in liter and bar, right, it will be 0.08314 liter bar, and temperature final is 284. So now you can solve it for pressure. It will come out to be approximately 0.84. 0.84 bar, the answer will come out to be, which is 84 into 10 raised to the power minus 2. Then number of water molecules not coordinated to copper ion is simply 1, because in copper sulfate dot 5H2O, 4 molecules, they are coordinated, right, to copper. So 1 molecule that is actually hydrogen bonded, that will be your answer. In diborane, of course, there are 6 bonds, right? 4 are the terminal regular covalent bonds, 2 center, 2 electron, and these are 2 banana bonds, which we call 3 center, 2 electron bonds. So total 4 plus 2, how many bonds are there? 6, right? In a linear tetrapeptide, of course, there are 4 amino acids and 2 amino acids have 1 peptide linkage, so there are 3 peptide bonds, so the answer will be 1, right? If polythene sample contains 2 monodispersed fractions in the ratio 2:3, that is molar ratio. So we can take the, so let us say there are, what is the weight, average molecular weight? Okay, so there is first, there is second type of fractions, right? A polythene sample. So the molar ratio is 2:3, so I can take this as 2 mole and this I can take as 3 mole, right? The degree of polymerization is how many units, right? So this has 100 unit, it has 200 unit. So the molar mass will be 100 into 28. So why not I write it directly? So 2800 gram per mole, right? And the second fraction has 200 degree of polymerization, that is 200 units. So that is 200 multiplied by this. So this will be 5600 gram per mole, right? By the way, polythene is CH2 double bond CH2. This is the monomer and its molecular mass is 28, right? So 100 fractions, 100 is the degree of polymerization, 100 units, so 2800 gram per mole is the molar mass, and here 200 units are present in a chain, so the molar mass of the entire unit will be, chain will be 5600 gram per mole. This is an addition polymerization. The weight of the chain is simply n times the weight of the monomer, right? Now the question is, what is weight average molecular weight? So weight average molecular weight is N1 M1 square plus N2 M2 square divided by N1 into M1 and N2 into M2, right? So now you have all the values. I will just write it for you. 2 into 2800 square plus 3 into 5600 square divided by 2 into 2800 plus 3 into 5600. So that if you work out, it will come out to be 4900 gram per mole, right? You can say. So the weight average molar mass will be 4900 gram per mole. While estimating nitrogen present in an organic compound by Geldel's method, the amount of evolved ammonia is from 0.25 gram of the compound reacts with 2.5 ml of 2 molar sulfuric acid. So we know that the reaction between sulfuric acid and ammonia is this, right? That means I can say number of moles of ammonia divided by number of moles of sulfuric acid, they are going to be 2:1, right? That is, if you are taking 1 mole of sulfuric acid, you need 2 moles of ammonia. Now number of moles is molarity into volume, so number of moles of ammonia, that will be molarity and volume of sulfuric acid. Molarity is 2 molar, volume is 2.5 ml, right? And this is 2. Okay, so number of moles of ammonia, it will be 2 into 2 into 2.5, right? So which is basically 10 millimole. Why millimole? Because the volume is in milliliter, right? So ammonia is 10 millimole, and we know that 1 molecule of ammonia contains 1 nitrogen. So nitrogen is also 10 millimole. Nitrogen is also 10 millimole, right? So the mass of nitrogen is 14, right? The atomic mass into 10, and millifactor is 10 raised to the minus 3. Millifactor is 10 raised to the minus 3. So now it's very easy. You can calculate the percentage of nitrogen as the mass of nitrogen which is 14 into 10 raised to the power minus 2 divided by what is the mass of the compound? 0.25, right? And then 100. So when you do this calculation, you will find that the percentage nitrogen is 56. Okay? In this question, 100 ml solution of CH3CH2 MgBr on treatment with methanol. So basically guys, this is Grignard reagent. They are very strong carbon ions. When it reacts with any compound that is acidic hydrogen, what they do is they just take away the H plus. So CH3CH2 minus will take H plus to form CH3CH3. So the gas we are talking about here is ethane, for which molecular mass is 30 gram per mole, right? Now we all know that 22,400 ml of a gas at STP, right, it is 1 mole, right? 22,400 ml of a gas at STP corresponds to 1 mole. For ethane, they should be 30 gram, right? So 22,400 ml should correspond to 30 gram for ethane, but we are getting how much volume? 2.24 ml, that's very little. So 2.24 ml would be 30 divided by 22400 multiplied by 2.24, right? ml, so ml and ml cancel. That will give your answer in gram. You multiply it by 1000, that will be milligram, so that will be 3 milligram, right? So that is the correct answer to this question. So that's all in this solution video guys. Thank you for watching.
Hi dear students, welcome to Infinity Learn by Sri Chaitanya. Now let us see the math part of the question paper dated 18th Jan, that is GTM 6, right? Fine. So in this, the first question, it is from complex numbers. You see, Z is a unimodular complex number. That means modulus is 1. So why can't you take Z as cis theta, isn't it? That is cos theta plus I sin theta. So that he is asking argument of Z square plus Z bar. You see my dear friends, Z square is going to be cis 2 theta, right? And Z bar is going to be cis of minus theta. Now if you add these two, sum of these two is going to be cos 2 theta plus cos theta plus my dear friends I into sin 2 theta minus sin theta, right? Now argument of this complex number is going to be, you can say, tan inverse of, you see, y by x, that is sin 2 theta minus sin theta by cos 2 theta plus cos theta. Okay, so this is going to be tan inverse of, this is sin c minus sin d, 2 cos c plus d by 2 sin c minus d by 2 by 2 cos c plus d by 2 cos c minus d by 2. So friend, these two get cancelled. You will get tan inverse of tan of c minus d by 2 is theta by 2, and hence this is theta by 2 my dear friends. Half theta is going to be argument of z, half we can say argument of z my dear friends, half argument of z. So option 1 is the right answer. Okay, next, you see the number of rational terms of this binomial expansion. There is a simple shortcut my dear friends, confirm both the bases are prime numbers. Now you just divide 1824 with the LCM of 6 and 9, so is going to be, we can say 18, right step. Then either 6 or 9 divides that, you have to write plus 1. If neither of these two divide, no need to write plus 1. But 6 divides this, so you write plus 1 my dear friends. This we can say step is going to be, you see, this is 101 plus 1 is going to be 102 my dear friends, because this is 101 point something, step is 101 plus 1, 102 is the answer. Next friends, this is a standard question. So A1, A2, A3, A30 are 30 sets with 5 elements each, whose union is going to be S my dear friends. Similarly, B1, B2, B3, Bn are n sets having 3 elements each, and even their union is also S. Now each element of S belongs to exactly 10 of AIs, and each element of S belongs to exactly 9 of BJs, then the value of n is. My dear friends, I mean to say, suppose there are 30 sets here, each set has 5 elements. Okay, let us put them on the ground. You are going to get 30 into 5, 150 elements. When you take the union of these, see, wherever we are having repetitions, we write only one element. Suppose the union is set S. Given that each element of S is there in exactly 10 of A's, that means out of 150, so after writing S, you observe that each element repeated 10 times, my dear friends. So the total number of distinct elements of S is going to be this. In the same way, for each Bi is having, you see, there are n sets, each set is having 3 elements, so we can say, yeah, 3n elements are there in total. Now union of all these is going to be S, and I can say, my dear friends, each element of S is there in exactly 9 of Bj's. That means out of these 3n, each element repeated 9 times, so the total number of elements of S is going to be 3n by 9, and hence we can say, my dear friends, so this is 15 into 3, n is equal to 45. 45 is the answer, my dear friends, right? Fine. Next, you see this question, given limit extends to 0, 1 minus cos x by, you see this is given limit extends to 0, 1 minus cos x by, you will go like e power ax minus bx minus 1. Right? If you just substitute, you will get 0 by 0. Just you take L'Hospital's rule, my dear friends. So its derivative is sin x by e power ax derivative a into e power ax minus b. When you put x tends to 0, numerator is 0, denominator is a minus b. A minus b must also be 0, my dear friends. Otherwise the limit cannot be a finite number other than 0. So a minus b 0 in the sense a is equal to b should happen. He is asking about a by b, which is 1. He didn't ask a and b values, so I am not proceeding further. If you want, we can also take again L'Hospital's rule and all, right? Next, my dear friends. Now, so here he has given C1, C2 are two circles of unit radius with centers, one center 0, 0, the other center is 1, 0 respectively. Okay. C3 is a circle of unit radius passing through the centers of the circle C1 and C2. So first you find C3 circle having its center above x-axis. Equation of the common tangent to C1 and C3, my dear friends, which does not pass through C2 is. You see, my dear friends, first of all you are having two circles. First circle is having center 0, 0, radius 1, this is 1, 0. Second circle is having same 1, 0 is the center, radius 1, this is the second circle, right? So C3 is a circle which is going to pass through these 2 points. So can you write a circle of unit radius, he said. You see, I want a circle which is passing through 0, 0. Can I write it as x square plus y square plus 2gx plus 2fy is equal to 0, because it is passing through 0, 0. Now it is also passing through 1, 0, substitute 1 plus 0 plus 2g plus 0 equal to 0, you get 2g value is minus 1, right? Moreover, so you can write it as x square plus y square minus x plus 2fy is equal to 0. Given its radius is 1, right? So C3 is a circle of unit radius. What is its center, my dear friends? Center is 1 by 2 comma minus f, right? Yes. So this is going to be radius is 1 by 4 plus f square minus 0 is going to be 1. F square is 3 by 4, f must be root 3 by 2, my dear friends. F must be plus or minus, so root 3 by 2, right, my dear friends. So here center is minus f. You can take a circle, you see, which passes through these two in the sense with unit radius. There will be two circles possibility here and down. For the above circle, you see center, it is, he said, above x-axis. That means for this center y coordinate must be positive, my dear friends. So minus f positive, f negative, you take f as minus root 3 by 2. So my dear friends, I can say the circle equation now like x square plus y square minus x, 2f is going to be minus root 3 y equal to 0. Now friends, equation of the common tangent to C1 and C3 which does not pass through C2. You see, I need to find, this is C1, right? I need to find this common tangent. Generally these two circles are of equal radius, right? So the common tangent must be parallel to the line joining the two centers. So one circle center is 0 0, other circle center is, you can say 1 by 2 comma, you can say root 3 by 2. This is going to be. So what is the slope of the line passing through these two? This is going to be root 3 is the slope, right? Slope root 3 means you can say root 3x minus y is equal to some k it is, right? So you see root 3x minus y combinations, two such are there. So since it is also having, this is the tangent to circle 1, perpendicular distance from circle center is equal to radius. If you just apply, you are going to get k value plus or minus 2. If you take root 3x minus y minus 2 equal to 0, you see you have to get x intercept negative, my dear friends. Minus 2 will have x intercept minus c by a positive, that means you are going to take this, so you have to take plus 2, my dear friends. Now x intercept is minus c by a, which is minus 2 by root 3, which is negative, so that it cannot intersect c2. So this is going to be the answer, my dear friends. You have to take the second option, right? If you take this option, you are going to get this line which cuts x axis, especially at, you see C2, it is also going to cut C2. So it should not cut, right? So that is the thing. Next, my dear friends, you see AB are two events in a random experiment such that probability of A is between 0 to 1, and he wants, you see, this is the basic definition of conditional probability. P of A given B is P of A intersection B by P of B. It is correct. This statement is true. Even here also P of A intersection B complement by P of B complement is the answer. P of B complement, you can write 1 minus P of B. A intersection B dash, in the sense, my dear friends, A intersection B complement is nothing but A minus B. A minus B you can also write like P of A minus P of A intersection B, because they are disjoint. P of A minus P of A intersection B is going to give A minus B, which is this. So this statement is also correct, my dear friends. So both the statements are correct, and it is a correct explanation even, because this is the basic definition to simplify this, right? Next, you see the variable tangent of the circle x square plus y square is equal to 1 intersect this particular ellipse. You see, my dear friends, this ellipse is going to be x square by 4 plus y square by 2 is equal to 1. So this ellipse maintains semi major axis 2, minor axis root 2, my dear friends. So this is 2. This is a circle with center 0 0, radius 1. So this circle will be like this. Now you see a variable tangent to the circle intersect the ellipse at P and Q. Suppose you take some tangent to this particular circle which intersects at P and Q to the ellipse, and tangents are drawn at P and Q where these two are going to intersect at some point, and we need the locus of that point of intersection. It is simple, my dear friends. If you take this point as S x1 y1, so this is going to be the chord of contact. So the chord of contact of the ellipse, you see, this is going to be the chord of contact of that point with respect to the ellipse. So chord of contact equation is S1 is equal to 0 for the ellipse. So you can write x1 plus 2y1 minus 4 equal to 0. Now this chord of contact has to touch our circle, this one. So since it is a tangent to this, just apply perpendicular distance from center is equal to radius. So center is 0 0 minus 4 by root of x1 square plus 4y1 square is equal to radius of the circle is going to be 1, my dear friends. So you can say x1 square plus 4y1 square is equal to 16. So x1 square by 16 plus y1 square by 4 is equal to 1. Now he is asking, what is he asking here? So what does it represent? It represents circle is wrong, parabola wrong, ellipse is correct, eccentricity latus rectum. So latus rectum is 2b square by a, 2b square is 4, a is again 4, which is 2. This statement is correct. Eccentricity you can find root of a square minus b square by this. So which is going to be 12 by 16. So 12 means it is 2 root 3 by 4. So this is wrong, and hence option D is the right answer. Next, my dear friends, there are 12 pairs of shoes in a box. Okay, then the possible number of ways of picking up 7 shoes, so that there are exactly 2 pairs. Out of 12 pairs available, my dear friends, you need to select 7 shoes and there should be exactly 2 pairs. So which 2 he didn't mention. Out of 12 you select 2, my dear friends, first of all. So you got 2 pairs, that means 4 shoes are done. Now you need to select 3 shoes from the rest of 10 pairs. So rest of 10 pairs 3 shoes, but no 2 shoe must be a pair. That means you need to take 3 different shoes from different pairs. So which 3? Select 3 pairs out of the 10. From these 3 pairs there will be 2 shoes, left or right, 2 possibilities. You can take left or right, left or right, left or right. So this is going to be your answer, my dear friends. Yes, 63360 will be the answer, right? Out of 12 pairs you want exactly 2 pairs, select 2, and so into, from the remaining 10 you have to get 3 shoes, because already you have selected 4 shoes, in fact 3 shoes, of which there should be no pair. That means you have to take 3 different shoes. That means from the remaining you can select 3 pairs, my dear friends. That means out of these 3 you can take left right or left right or left right. So these are the things. Next, see, this is a simple working, my dear friends. A is given, you just find 3a square, 12a, then adjoint, right? It is simple, my dear friends. You see, a square you can find, I don't think you require this simplification here, minus 4 comma 1, which is 2 minus 3 minus 4 1. So which is, my dear friends, this is first row first column, 4 plus 12, which is 16. This is minus 6 minus 3 minus 9 minus 8 minus 4 minus 12. This is 12 plus 1, 13. This is a square. So I want 3a square will become, you see, 48 minus 27 minus 36, 39. Similarly 12a is going to be, my dear friends, it is 24 and minus 36 minus 48 and 12. So 3a square minus 12a, you just subtract, my dear friends. 24 you are going to get, this is here. So first element is going to be, this is 3a square, this is 4 plus 12, 16 into 3, 48 minus this, you are going to get 24, and next element, this is, my dear friends, minus 27 plus 36, it is going to be 9, and minus 36 plus 48 is going to be 12, and this is the last element, 39 minus 12 is going to be 27. And how to find adjoint of a matrix, my dear friends? So interchange these two and change the sign, 27, 24, minus 9, minus 12. This is the answer. So this is going to be your answer. That's it. So for a matrix, especially a 2 by 2 matrix A, B, C, D, adjoint is going to be interchange A and D, minus B minus C is the adjoint of the matrix. That's all, my dear friends. Next, you see, this is given for x1 minus 8 kind of items. Sum of the items is given, sum of the squares is given. He is asking the standard deviation of x1 to x18. You just find the standard deviation of x1 minus 8, x2 minus 8 and so on, x18 minus 8. How to find standard deviation? Square root of sum of, you see, sigma xi square is 45 by number of items is 18 minus mean is going to be sum of the items by number of items square. Because friends, let me write the formula, sigma xi square by n minus sigma xi by n, or average square, under root gives the standard deviation, right? So my dear friends, this is going to be, you can say 5 by 2 minus, this is 1 by 2 whole square is 1 by 4, which is 10 by 4 minus 1 by 4 is 9 by 4, which is 3 by 2, my dear friends. Yeah, 3 by 2 is standard deviation of these items. For each entry, if I add 8, no change in standard deviation. So for this entries also standard deviation is 3 by 2 itself, my dear friends. Be careful with standard deviation or variance, whether he is asking this or that, okay. Next, my dear friends, so f of x is given 4x minus 1 whole cube. So you see, this is x by 3, this must be x square, this is printing error. You can do, my dear friends, 4 power x minus 1 whole cube by, this is sine of x by p into log of 1 plus x square by 3. This is the expression given, and this is continuous at x is equal to 0. F of 0 is given, so limit extends to 0 should also be this. Try to find limit extends to 0, my dear friends. So since it is cube is there, you write x here so that you will get x cube, you write x here and you write x square here, my dear friends. So x cube got cancelled. So next point, so you write here x by p, so you write p here, x square by 3, you write 3 here, my dear friends. So friends, this becomes 1 as extends to 0. This also becomes 1 because limit extends to 0, log of 1 plus x by x will become 1. So 3p will go up, and this is log 4 is the limit. 4 power x minus 1 by x means log 4 base e. So finally this is 3p into log 4 whole cube is the answer. He has given the same, so but 12 is kept, so 3p is going to be 12, p value is 4, my dear friends, okay. Next, you see sine inverse of, this function can be simplified like sine inverse of, you see this is opposite side by hypotenuse kind of, so definitely it is positive. So you try to write the same expression root x minus 1 by root of x into x plus 1. You can comfortably convert into tan inverse of, opposite side is the same, if you just compute adjacent side it will become root of x into root of x minus 1. You just see, my dear friends, hypotenuse square minus side square under root you do, you are going to get the same. So it is like tan inverse x minus y by 1 plus xy, denominator positive, so you can write tan inverse root x minus tan inverse root of x minus 1. Yes, so yeah, he is just asking the derivative of this, tan inverse x derivative 1 by 1 plus x square into root x derivative is 1 by 2 root x minus tan inverse x derivative 1 by 1 plus x square will become x, my dear friends, into 1 by 2 into root of x minus 1. Now you just take 1 by 2 common, you are going to get root x into x plus 1 minus 1 by x into root x minus 1. Option 1 is the right answer. Next, my dear friends, this is the differential equation given. So dy by dx, this is LDE, right? dy by dx plus p of x into y is equal to q of x. So first of all, integrating factor is e power integral p dx, cot x dx. So e power log mod secant x, right? Because cos x by sin x derivative is minus integral cos x is log mod secant x, right? Plus c. So this is going to be, you can say just like secant x, because we are discussing around pi by 2, pi by 6, it is secant x. So general solution is y into integrating factor is equal to integral of integrating factor into the given function q of x dx, which is, my dear friends, y secant x is equal to integral dx is x plus c. So now to find c, given at x is pi by 2, it is 1 by 2, so 1 by 2 and secant 91 is equal to x is pi by 2 plus c, my dear friends. So you can say here c is going to be 1 minus pi by 2. So finally y is equal to secant x plus 1 minus pi by 2 plus x it is. Now I want y of pi by 6. You just substitute, my dear friends. So cos 30 degrees is root 3 by 2. So y into 2 by root 3 is equal to, you can take x is equal to, you can say, my dear friends, 6 by pi. You just simplify, this is 1 minus pi by 2 plus 6 by pi. You just see the calculation once, my dear friends. You see, integrating factor is e power integral p dx. So log integral tan x is log mod secant x, integral cot x is, we can say, log mod sin x. So we guess we went wrong there, so we will do it again, LDE. So integrating factor is, my dear friends, e power integral p dx, p is cot x dx, so which is cos x by sin x, integral f dash x by f of x log mod f of x, which is, my dear friends, e power log of sin x. So which is, I can say, sin x is the integrating factor, my dear friends. So the general solution is y into integrating factor is equal to integral of, integrating factor is sin x into q of x is cos x dx, my dear friends. So this is y sin x is equal to half integral sin 2x dx, which is half sin 2x integral is minus cos 2x by 2 plus c, my dear friends, which is, I can say, minus 1 by 4 cos 2x plus c. Now to find c, you can give this substitution, put x is pi by 2, output is 1 by 2. 1 by 2 sin 90 degrees is 1. So this is cos pi is minus 1, this becomes 1 by 4 plus c. So c is going to be 1 by 4, my dear friends. So I can say it is going to be y into sin x is equal to minus 1 by 4 cos 2x plus 1 by 4. Right. Now I want when x is pi by 6 output, put pi by 6, my dear friends, output y I require sin 30 degrees is 1 by 2 minus 1 by 4, this is 60, cos 60 is 1 by 2 plus 1 by 4. So friends, y by 2 is equal to, you can say, 2 by 8 minus 1 by 8 is 1 by 8. So you can say y is equal to 2 by 8, which is 1 by 4, my dear friends. Fourth option is the right answer. Be careful with calculation, right? Next, you see the area bounded by the curve y is equal to cos x and y is equal to sin x between the ordinates x is equal to 0 and x is equal to 3 pi by 4. You just take, my dear friends, cos x graph at 0 1, at pi by 2 0, at pi this is minus 1. This is cos x graph. Sin x graph at 0 0, at pi by 2 1, at pi it is 0. Let it be pi, this is pi by 2, this is 0. Undoubtedly this is pi by 4, my dear friends. He is asking about the area between these two curves, and x is equal to 0 is this curve, my dear friends, and x is equal to 3 pi by 4. You can just take 3 pi by 4 here. This is x is equal to 3 pi by 4. So he requires this area, my dear friends, bounded between these two curves and the vertical ones. This is the area he is expecting. So my dear friends, it's simple. The point of intersection is pi by 4, integral 0 to pi by 4. Here upper curve is cos x minus lower curve is sin x dx plus integral pi by 4 to 3 pi by 4. Undoubtedly upper curve is sin x minus lower curve is cos x dx. You just simplify this integral, you will get the answer. Mostly you are going to get the 2 or 3. Just simplification. Integral cos x is sin x is minus cos x. Substitute the limits, you will get. You see, shall I do cos x integral is sin x plus cos x, let me write, between the limits 0 to pi by 4 plus sin x integral is minus cos x minus cos x integral is sin x between the limits pi by 4 to 3 pi by 4, my dear friends, right. So here what we are going to do is, you just substitute pi by 4, 1 by root 2 plus 1 by root 2, 2 by root 2 means you will get root 2 minus, when you put 0, sin is 0, cos is 1, root 2 minus 1 is this area, my dear friends, plus you can also take minus common completely, minus of sin x plus cos x, 3 pi by 4 if you substitute, the sum becomes 0, minus, when you substitute pi by 4, you are going to get, you see, 1 by root 2 plus 1 by root 2, 2 by root 2, which is root 2, my dear friends, which I can say plus root 2, that is root 2 minus 1 plus root 2, 2 root 2 minus 1, third option is the right answer. Simplification, simple, right? Next, you see, a tetrahedron has vertices O, here A is missing, my dear friends, actually printing error, typo error. So B, C are given, the angle between the faces OAB and ABC. So A must be given. So now you just want OAB is a face, OAB is a face, ABC is another face, ABC is another face, okay. So you need the angle between the faces, face means plane, that means you need to find the normal DRs of OAB plane. So if A is given, you just find OA bar, you see OB bar, OB bar DRs you see 2, 1, 3 itself. Similarly OA bar is given, so you can find their cross product, OA bar cross OB bar gives the vector perpendicular to this plane. Similarly here, this is ABC, right? You can write AB bar, AC bar if A is given. So you just find the cross product of these two, you will get a normal vector to this face. The angle between two planes is nothing but angle between their normals. For these two, suppose you got it as C bar, this is D bar, you can just find cos theta is equal to C bar dot D bar by magnitude of C bar into magnitude of D bar will give you the angle. So since A is missing, I am not working the things, you just, this is the procedure, we can find the angle between the two planes or two faces. Next, my dear friends, you see f of x is given as mod x minus 8 and g of x is f of x, and given x greater than 16, g dash of x. Array yaar, g of x is f of x. Array, what is f of x? Mod x minus 8. F of something means modulus of, you see, something minus 8. F of something is nothing but something minus 8 with modulus. This is something minus 8 with modulus. Since x is greater than 16 case we are discussing, mod x minus 8 you can write x minus 8 itself, which is mod x minus 16. But still x is more than 16, this is x minus 16, my dear friends, undoubtedly. So when g of x is x minus 16, its derivative is 1, that's it, a linear expression, okay. Next, you see here it is given integral 0 to pi by 8 sin x by x is given as pi by 2. If this is the case, what could be this? Integral 0 to infinity sin cube x, you can write 3 sin x minus sin 3x by x dx, my dear friends, because sin 3x is 3 sin x minus 4 sin cube x. So you can write 1 by 4 here. So 4 that means you can write 1 by 4 here and supply 4 here, you can write 3 sin x minus sin 3x. Now you just separate, my dear friends, 1 by 4 into, you can say 3 times integral 0 to infinity sin x by x dx minus integral 0 to infinity sin 3x by x dx, my dear friends. This is the one. So and hence you can write this is 3 by 4 into this is pi by 2, it is given as pi by 2. Here, my dear friends, minus 1 by 4 into, why don't you take 3x as t? If you take 3x as t, my dear friends, x becomes 0, t becomes infinity, this is sin t, x is t by 3, my dear friends, into 3 dx will become dt, this is dt by 3, 3 got cancelled. So my dear friend, this is 3 pi by 8 minus, this becomes again like the same structure, it is going to be 1 by 4 into pi by 2, my dear friends. So 3 pi minus pi, 2 pi by 8 it is, my dear friends, which is pi by 4. Pi by 4 is the answer, my dear friends. Okay. Next, you see the next question, it is a simple integral. You see, this is a standard formula you can derive, or in all such cases we just take tan x by 2 is equal to t, my dear friends. You just substitute a is 4, b is 5 in this, you will get this. So simply you can substitute and try, my dear friends. 25 minus 16 is going to be 9 under root is 3, a is 4, you see, a into tan x by 2 plus b minus root of b square minus a square. You can just compute, my dear friends. So you can say b is going to be 5 minus 3, here you will get 2, here you will get 2, here this is, I can say 5 plus, I can say 5 plus 3, it is 8. You can just take 2 common in the numerator and denominator, you are going to get, a is 4, right? You can just take 2 common here, 2 tan x by 2 plus 1 by, this is 2 tan x by 2 plus 4. This is perfectly correct, my dear friends. So if you just take 2 common here, you can also take 2 common here. If not, that goes into constant part, no issue with that too, my dear friends. Okay. So because if you take 2 common here, log 2 plus log of this, so 1 by 3 into log 2 can be sent in integration constant. So this is correct explanation. Now how to prove this? Here we just do like, so sin x you can write tan x by 2 is equal to t. If you take tan x by 2 is equal to t, my dear friends, 1 by 2 into secant square x by 2, you are going to get, yes, into dx is going to be dt. So you will get dx is equal to 2 dt by 1 plus t square, you can write. So that, my dear friends, this becomes 1 by a plus b into sin 2x in terms of tan, you can write 2t by 1 plus t square, you can write, into dx can be written as 2 dt by 1 plus t square. So which is, friends, integral you can write here like a t square plus 2bt plus, you can say a, here 1 plus t square gets cancelled, 2 comes here, dt. This is, you can complete this now by completing the square method. A can be taken common, or completing the square method you can write, you are going to get in the same pattern, my dear friends. So I mean to say this is correct, and you can remember it as a shortcut even. Our procedure is also simple. So this is nothing but correct explanation of this. I have taken a is equal to 4, b is equal to 5. Both are correct and it is the correct explanation. Okay. Next, my dear friends, the ratio of sum of first 3 terms of a GP to the sum of first 6 terms. You see, suppose in a GP let the first term be a, common ratio be r, sum of first 3 terms means a r power n minus 1 by r minus 1 will be, sum of first 6 terms is a r to the power of n minus 1 by r minus 1. This ratio is given as 64 by 91, my dear friends. A gets cancelled. So this is a cube minus b cube. If you write, you will get r cube plus 1 is equal to 64 by 91, which is r cube plus 1 is, you can say 91 by 64. So r cube is going to be 27 by 64, which is 3 by 4 whole cube, my dear friends. Yes, so he is asking about the common ratio, which is 3 by 4. That's it. Next, you can say, you see, this particular statement is logically equivalent to simple, my dear friends. There are only 2 parameters PQ for support negation P, negation Q here, negation Q. So PRQ you can write its negation. Negation of PRQ you can write directly. Negation P and Q also you can write. So I want to take R in these two. So only 4 cases, my dear friends: true, 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 false, false, true, false, false. Negation P is false, false, true, true. Negation Q is false, true, false, true. Now P or Q, you know well, in 3 cases true, this case false. Its negation, it is false, 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 true. Now negation P and Q, negation P and Q will be, you can say this is false, and this is true, this is also false because it is AND. Now OR in these two, if you apply OR, this is false, my dear friends, false, next false, next true, false, false, true, true. I can say, my dear friends, is it negation P? False, false, true, true. Perfect. First option is the right answer. Okay, simple. Next, you see, coming to numerical answer type questions, let Pn be the ordinate of the point on the hyperbola. You see, you can just select one point like 97 secant theta, comma 79 tan theta. This is the general point on it. Ordinate is going to be, my dear friends, so a secant theta comma b tan theta is the point on this. So we can say, my dear friends, here let Pn be the ordinate of the point P on the hyperbola, and the tangent at P meets the transverse axis in T2 and O is the origin. That means, my dear friends, if you just take this particular hyperbola, you just take some point, you just take the tangent here. So tangent cuts this particular, suppose this is origin, he is asking about this point is T, my dear friends, O is the origin, okay. He is asking about ON into OT, Pn be the ordinate of the point P. That means from here he has dropped a perpendicular onto y axis, this is Pn, my dear friends, this is P, and I can say this is going to be, this is PT here, this is going to be PT. Now he is expecting OT into ON, OT into ON, this distance he is expecting, my dear friends. ON is nothing but x coordinate of the P, of the point P, 97 secant theta. So you can just find tangent equation, my dear friends, here at the point P, and suppose xx1, this is xx1 by 97 square minus yy1 by 79 square is equal to 1. So where does this intersect x axis, friends? Put y coordinate is 0, so x value is 97 square by x1, which is 97 square by x1 is going to be 97 secant theta. We can say this is 97 cos theta, my dear friends. So this x coordinate is for this point 97 cos theta, so OT is going to be 97 cos theta. So product of these two by 2011 with step, my dear friends. So these two get cancelled, 97 square is 9409 by 2011, which is 4 point something, and hence the step is going to be 4, my dear friends. That's all. Next question, alpha, beta, gamma are 3 angles in 0 to pi by 4. This is a simple relation connecting them. You just simplify, my dear friends, you will get like tan alpha plus tan beta plus tan gamma minus tan alpha, tan beta, tan gamma is equal to 1 minus tan alpha, tan beta minus tan beta, tan gamma minus tan gamma, tan alpha. If you just simplify this particular condition, you are going to get this. So if you take this by this, this is just like tan of alpha plus beta plus gamma is equal to 1 kind of, if you just bring in the denominator. So alpha plus beta plus gamma is going to be tan of, he asked tan of alpha plus beta plus gamma, this is going to be 1, my dear friends. That's all. Next, you see this question, f of x is a function given in from integers to integers defined by f of x is n plus 3 if n is odd, n by 2 if n is even. Now k is odd and f of k is going to be 27, then the sum of the digits of k. Friends, given k is odd, basically if k is odd, f of k is going to be k plus 3, my dear friends. So odd plus 3 will become even, k plus 3 is even, so I can say, my dear friends, this is f of even number is that n by 2, that is k plus 3 by 2 is equal to 27. Now k plus 3 by 2 may be even, may be odd. If this is even, my dear friends, k plus 3 by 2 will become by 4 is 27, which is 1 k is equal to 105. Here you see k is odd, perfect with this, and sum of the digits of this is going to be, you can say, 108 minus 3 is 105, sum of the digits is 6. Suppose if k plus 3 is odd, so you are going to get k plus 3 by 2 plus 3 you will get is going to be 27. So 27 minus 3 is going to be 24, 24 into 2 is going to be 48 minus 3, k is 45. You just check with k is equal to 45 in reverse order, you may not get the 27 one. You just check which holds good, this holds good, my dear friends. So I can say, because 45 if you put in first f, you will get 48, 48 by 2 is 24 is even, 24 by 2 you are going to get 12, not 27. So this will not satisfy the original equation, so this is the only answer. Sum of the digits of k is going to be 6. Next, you see a simple quadratic equation in terms of when trigonometric, cos square theta you write 1 minus sin square theta, you will get, my dear friends, sin square theta minus sin theta minus 2 equal to 0. You see clearly sin theta is equal to minus 1 is one root, other root is 2, but sin theta is equal to 2 is impossible in the integral 0 to 2 pi. You see sin theta becomes minus 1 at only one solution, so number of solutions is going to be 1 itself. Next, my dear friends, the number of ways of selecting 10 balls out of unlimited number of white, red, green, blue. Total you need to select 10. Maybe like 0, 0, 0, 10, 0, 0, 1, 9, like this. So number of so you can take x these, y these, z these, w these, x plus y plus z plus w is 10, and each can be x, y, z, w must be less than or equal to 10. So number of non-negative integral solutions, n plus r, n items, 4 boxes, n plus r minus 1, c r minus 1, which is 13c3 is going to be the answer. 13c3 means 13 into 12 into 11 by 3 into 2 into 1, which is 2 times 11 into 13 is 143, 286 is the answer. That's it. Okay. Next, my dear friends, the distance of the point from the plane measured parallel to particular line. You see friends, plane, point, perpendicular distance we have direct formula, but the distance is measured parallel to some line. So this is that line, right? So my dear friends, there are two ways. Already this point is there, 1, minus 2, 3. This line drs are 3m1. You just take, because parallel to this 3m1 drs. You just find the general point on this line, substitute in the plane, and you make it equal to 0, you will get m value, my dear friends, and m and lambda value you will get here. So then you can find the distance. Already he has given, of course, m is a parameter, t is a parameter. You will get some condition in terms of m and t. You just apply this distance is equal to root 7 by 2, you will get m value. Rather, the direct formula is you see, from this point to this measured parallel to some line. So substitute this point in this particular plane, 1, minus 2, minus 9, plus 10, which is, you see, 1. This is going to be minus 4, in fact, my dear friends, minus 4, minus 9, plus 10 by, you see, we just write like root of a square plus b square plus c square, right? This is going to be this drs 3 into dc's you have to write. Here x coefficient is 1 into, here dc is 3 by root of 3 plus 1, 9 plus 1, 10 plus m square. This is point, and next coefficient is 2 into m by root of 10 plus m square. Then next minus 3 into, we can say 1 by root of 10 plus m square. This is the distance, my dear friends. Actually it is like, the formula is like ax1 plus by1 plus cz1 plus d by, you can write a cos alpha plus b sin alpha plus c cos alpha cos beta c cos gamma. That means the DCs cos alpha, cos beta, cos gamma are the DCs of the required line. So I found the DCs of these three, I have substituted. Here, my dear friends, 11 minus 13, 2 by, these two got cancelled, 2m into root of 10 plus m square is given as root of 7 by 2, my dear friends. So you just square 10 plus m square into 2 is equal to 7m square, my dear friends. So 5m square is equal to 20, m square is equal to 4, my dear friends. M must be plus or minus 2, mod m is going to be 2. That's all. Either you can do the procedure or the formula. Next, there are three coins. One is two-headed coin having head on both faces. Okay, that means one coin is having both heads. Other is partially biased coin, comes up 75% of the time, and third, so head comes up, coin that comes up head 75%. That means it can give head tail, but for this, when you toss, getting head is 100%, probability is 1, here 75%, 3 by 4. Third is an ordinary coin, so probability is 1 by 2 to get head, my dear friends. Now, so one of the three coins is chosen at random and tossed. If it shows head, then the probability that it was two-headed coin P, then the value of 81P. You see, my dear friend, Bayes theorem application. Total probability theorem. What is the chance that if a coin is taken and tossed, it shows head? You see, when you pick up a particular coin out of these three, getting this coin chance is 1 by 3, then getting head probability is 1. Next, for second coin chance 1 by 3, in that case getting head probability is 3 by 4, and for third coin chance is 1 by 3, getting head probability is 1 by 2. So this is total probability. Out of this, I want the case that coin to be this one. He said two-headed coin, that is 1 by 3 into 1. So you can cancel 1 by 3 in all, you are going to get 1 by, you see, 4 by 4, 3 by 4, 1 by 2, you see, 4 by 4 plus 3 by 4 plus 2 by 4, which I can say 4 by, you can say 9. 4 by 9 is the probability, which is P, my dear friends, but he is expecting 81P. 81 into 4 by 9, 36 is the answer, my dear friends, 36 is the answer. Okay. Next, my dear friends, the least integral value of A for which this particular inequation is true. You see, a particular expression is always positive in the sense it should be upper parabola. A minus 3 must be positive and delta must be completely negative, otherwise it comes down. Delta means delta is equal to b square minus 4ac must be negative. So b square minus 4 times a minus 3 into a plus 6 must be negative, my dear friends. You can say 4 times 36. 36 minus of a square plus 3a minus 18 is less than 0. So you can say 36, 46, 56, 54 minus a square minus 3a less than 0. So I can say a square plus 3a minus 54 is greater than 0, which I can say, friends, a minus 6 into, see, we can say here 9 and 6, a plus 9 is greater than 0. So a must be less than minus 9 or a is greater than 6. So other case you are going to get negative, but I already got a greater than 3, so a must be greater than 6, my dear friends. The least integral value of a is going to be 7, my dear friends, because he said it is strictly greater than 0, so equal to 0 is not allowed, so a must be greater than 6, so 7 is the possibility. Next, the triangle ABC, the equations of the altitudes AM, BN. In triangle ABC, my dear friends, you can say equations of altitude AM is given completely, and you can say BN is also given, but K unknown is there, and the altitude of CL, another altitude CL is also given. You know, all the altitudes are concurrent at the point called orthocenter. This is given completely. I want the unknown K. It is very simple. You just find the point of intersection of these two. You will get the orthocenter. You are going to get 1 by 2, 1 by 2 as the orthocenter, my dear friends. So this must lie on the second, third altitude also. Substitute 1 by 2 plus 1 by 2 is equal to K. So K value is 1, my dear friends. Or else the 3 lines are concurrent, that is equal to 0 is also fine. Okay. Next, you see, in a triangle plot ABC with BC is 7, CA is 8, AB is 9. So my dear friends, this is, suppose this is ABC, you can say given BC is 7, CA is 8 and AB is 9. A lamp post is situated at the middle point E of the side AC. Here some lamp is kept, my dear friends. Okay, which subtends an angle of tan inverse 3 it is. Tan inverse 3 means this is the ground, this is the height, this angle theta is such that tan theta is equal to 3, okay, at the point B. Now the height of the lamp post, fine. One thing is, since it is midpoint, this is 4, this B, we can say this is going to be E. BE is the median, my dear friends. In a triangle, how will you find median? Apollonius theorem. This is 7, this is 9, this is 4, my dear friends. How will you find the median M? You see, Apollonius theorem is 7 square plus 9 square is 2 into 4 square plus M square, my dear friends. This is 81 plus 49, 130. Okay, so 130 65 is equal to 16 plus M square. So we can say, my dear friends, so M square is equal to 49, so M is equal to 7, my dear friends. If M is 7, so this length is going to be 7, my dear friends. Now you just see this right angle triangle where this is B, this is E, this is some other point, here 90 degrees, this here tan theta is equal to 3, H I want this is 7. So H by 7 is equal to 3, H is going to be 21 units, my dear friends, meters, because the others are in meters. That's it. So my dear friends, with this we've done this particular question paper. The paper is very comfortable and easy paper. You can comfortably score, I can say, out of 100 you can touch 90 plus easily. Okay, right.